Assalamu alaikum. So, this is a presentation on the project we made for our semester, which is we'd like to call an all in one robot using Arduino Nano and ESP32 microcontrollers. Our group is comprised of me and three other um, batchmates. Our instructor is Umar Farouk. And without further ado, here are the contents of our presentation or our report. Starting off with the problem statement, discussing the issues at hand and how this project might be useful for those issues. The objective of our project, which pertains to the previous problem statement, the task and the scope of our project. Um, and then further, we'll be discussing the hardware, components we used for our project, the schematic design we made on Easy EDA, along with the block diagram, um, PCB design plus the 3D display, and finally our hardware implementation. We'll also be providing the codes for both the ESP32 and Arduino Nano. And finally, to conclude our presentation, we'll be discussing the work division, expected outcomes of our project, the final result, and a conclusive end. So the problem statement: design and build a rubber line following robot that must follow any random given path. It's supposed to follow any black or white surface using an array of 5 infrared sensors. And it also has a range of resources or sensors, including voltage and current sensors, an ultrasonic sensor for detecting obstacles and avoiding them, a color sensor to detect distinct colors. We also are integrating a OLED display, which will basically um, show all the data that we're collecting from the sensors. And that same data gets stored in an SD card. But with the help of our ESP32, we can also transmit all of that data wirelessly to any device of our choice. And we'll be elaborating on that further in the presentation. Starting off with the ESP32 microcontroller, we'll be using it for Bluetooth control and Wi-Fi capabilities. Again, Wi-Fi so that we can transmit all that data to any device of our choice and keep those logs. OLED LCD display, 0.96 inches, to provide real-time data that is being collected by our sensors, including the voltage readings and current readings, which will be very helpful if we want to protect our circuitry. We can be sent an alert when those values exceed the maximum requirement. We have voltage sensors, current sensors, speed encoders, which are integrated with the ESP32. So the ESP32 is basically connected to all of the sensors which collect data. The Arduino Nano is responsible for the movement and traversal of our robot, which includes integration of the L298 Mini that we've implemented, used for motor control. We also have the IR sensor array, which is integrated with the Nano, and the ultrasonic sensor. So these two pertain to the movement and traversal of the robot. We also have the color sensor, which again is being displayed on the LCD display, which is why it is also connected to the ESP32 microcontroller. So the goal is to have an overall system integration where each device operates cohesively and produces the results that we expect or that we desire for our specific objective. The scope of our project is pretty dynamic because a lot of things are included in this robot, and this can be used for a variety of applications. So the components comprise of an Arduino Nano microcontroller. We'll be using both its digital input-output pins and its analog pins. The analog pins will especially be useful for the IR sensors or IR sensor modules that we have. Besides that, we have the power supply, which is a 9-volt battery. We also have resistors and capacitors throughout. Capacitors as filters and as or used for noise cancellation. Breadboard jumper wires. We have reflective tapes to test our robot. Obviously, we have the OLED, the encoders, L298, micro SD card module, voltage sensor, current sensor, color sensor, and in addition to that, miscellaneous components, we have connectors and headers, switches, LED indicators. Here's our schematic and block diagram. In the schematic, you can see how, but just by the way it's organized, we have most of the sensors on the right side. We have the microcontrollers on the top left. We have the microcontroller header pins on the bottom left. Those header pins are added to the design to be used as extra pins if we want to add or if we want to integrate more devices to our robot that are external to the actual PCB circuitry. Um, as you can see, we have all those filter capacitors. We have all of them connected with those net ports, which basically make connections without actually wiring those devices together on the schematic. And the block diagram basically demonstrates our working of the robot. You can see the battery and the current and voltage. Those arrows point to the Arduino, which means that they're actually supplying to the Arduino. But there's an arrow going from the Arduino to the LCD, which means that the Arduino is actually supplying data to the LCD and also powering it for it to be displayed. The ultrasonic SD card both provide to the Arduino along with the encoder. The Arduino then powers the motor driver, which powers the motor wheels. And moving on, we have our PCB and 3D design. So the PCB, we used a power plane generator on Easy EDA, and the 3D design was especially useful when we first began to implement the hardware because we also need to keep in mind the size of each component and how everything must be laid out so that it doesn't contradict the other's placement. Here is the final hardware, which pertains to the PCB we made previously. We have all those devices integrated. The color sensors and the IR sensors are at the bottom so that they can detect, while the ultrasonic is at the top to detect obstacles. We have the micro SD card right behind the ultrasonic. We have the two microcontrollers, and we also made an addition where we have a power button that, when pressed, will power the microcontrollers, and then the controllers will therefore power the rest of the components. Here's the code for our ESP32. We have all those libraries included. We have the SDA pin, the SCL pin. Um, And yeah, in this we've included the voltage sensor and the current sensor. Voltage pin is 34 or digital 34, which basically is an ADC pin, analog to digital converter, which will take analog values from the voltage and current sensor and convert it to DC so that it can be interpreted and displayed on the LCD while also being stored in the SD card. Um, We also have all the other sensors integrated. We also have Bluetooth serial libraries included, which will help in Bluetooth control. Um, More for the OLED display and for the color sensor. Because we have a color sensor which has 4 pins from S0 to S3 for interpreting the color. And then there's an output pin which sends an analog value to the ESP32. We've scaled it with frequency by 20%. We also have the distance calculator, which is made use by the encoders and also the ultrasonic. Besides that, we have more equations for the color sensor, and for the OLED, we have the print values based on whatever values we receive. We'll be displaying that, and then we have the Arduino Nano code. So we discussed before that the Arduino is mainly responsible for the IR sensor array and the ultrasonic, which pertain to the movement. In this, we've included the PID system because we have five IR sensors included. We've set up the KP, KI, and KD values, and we've troubleshooted them to find the best match for our specific robot design. And those values will be displayed on the OLED as well. Finally, we have the work division for our group. So this is basically um, the primary and secondary tasks that are obviously our group. Every single member has contributed to every single aspect of the project, but some have been responsible for a or more responsible for a specific aspect of the project, and that is why we've labeled them as primary. And secondary is where we've contributed to someone else's primary, and where we've simply contributed as a team and tried to find a solution cohesively. So our first group member is responsible for hardware implementation and the final report. Uh, Secondary contributions include components research, circuit design on Easy EDA, and coding. Myself, Osama, I'm responsible for the circuit design in the initial stages and the hardware implementation along with Arsh. Secondary tasks include components research. This again was a secondary task for me because I was mainly responsible for the design. I also helped with the report and contributed to the coding. Talal was responsible for components research. He was at the forefront of this task, and he was also the main person for our coding for both microcontrollers. Secondary tasks include report, hardware implementation, and circuit design. And lastly, Omar Farouk, he was responsible for the components research, hardware implementation, and secondary include report, coding, and circuit design. Expected outcomes, we expected the project to function relatively well because we also have a lot of components integrated together, and we could have a number of issues like the supply of current being less than the minimum requirement. We could have flux residue. We could have dry soldering, things of that nature. There could have been a lot of issues, and we expected to resolve every single one of them. Um, our project in the end was partially functional. It wasn't entirely. Our motor drivers worked, but they weren't able to detect or respond to the line detection properly, which can be diagnosed as an issue with the battery supply. There might not have been enough supply for the IR sensors for them to be able to send proper signals back to the microcontroller, which can then be interpreted. Uh, so a number of issues. In the end, it was partially functional, but there were some issues which overall ended up hindering the functionality of the circuit. So in conclusion, we got to learn a lot about all the different components. We got to learn about alternatives to our standard components, like using an L298 mini instead of an L298, so that we can have a fully embedded system. Choosing the right display, choosing the right sensors, and overall, conclusively, we were able to implement this design and uh, educate ourselves on comprehensive systems and integrated systems, along with design tactics and implementations. And this will be very crucial for any projects that we do ahead of this. So, just briefly, we've also created GitHub files. I can show you right here. So, here we have the 3D design uploaded on GitHub in this entire file, and it's public. We have the Nano code, ESP code, everything we discussed from the report. We have the Gerber file from Easy EDA, which can be used to manufacture this PCB on JLC or any other website. This is a picture of our hardware right here, as we showed in the report. Here's our license. So we chose a GNU General Public License because we obviously want people to be able to use our product, use our design, but we also want to be credited for this design. And so this general public license basically, even if people modify our PCB design or our codes, they should still operate under the same license so that we're referred to as the original creators. Whereas if we didn't have this license, anyone can use our code, modify it, and it would appear as if it's original to them. So this license basically protects us from that sort of issue. We also have our PCB design screenshot, which is included in the Gerber file, and a README file. A README file, which includes the entire information we had in the report. It'll brief you on the functionality, and if anybody wants to modify it, they will have sufficient information within this file to be able to understand the functionality and edit it based on whatever implementations they want to incorporate. And finally, we have our schematic picture. Again, the same picture that we had in the report. And that's all for our presentation. Oh, we also have a LinkedIn post right here, credited under my name. We have the picture for our 3D, or not 3D, hardware implementation. Here's another picture from above showing all the different components. We have the L298 Mini, ESP32, OLED display. The battery case is below the car. Arduino Nano, we got the power button right here. We got the regulator circuit right here with the filter capacitors, voltage sensor, current sensor, micro SD card. These holes you see right here, this is actually the IR sensor array, which is at the bottom of the PCB. It's on the underside, and you can see it right here. It's beneath, same as the color sensor. You see the holes right here ahead of the ultrasonic. It's actually soldered at the bottom underneath so that it doesn't come in the way of the ultrasonic. And here we also have the 3D design, um, PCB design, and of course the schematic. So that's it for our presentation. Thank you for listening.